vena cava right here. And if it's coming from the lower extremities or the abdomen, it's going to be coming from the into the inferior vena cava. All right here. Or if it's coming from the heart itself, it's going to be coming in via the coronary sinus. All right. So those are the three structures that open within the right atrium. This heart's become attached to me. All right. So now we're in the right atrium, which is deoxygenated blood. And by just pressure gradient, blood will flow from the right atrium through the right atrioventricular valve into the right ventricle. So blood in the right ventricle is going to be deoxygenated blood. All right, everybody know on your hearts where the right ventricle is? Okay. Yeah. Now the right ventricle contracts. At the same time, the left ventricle is contracting, but we're following a drop of blood, not the cardiac cycle itself. So the right ventricle contracts and pushes the right AV valve closed and pushes eventually, in a few fractions of a second, the pulmonary semilunar valve open, and blood flows, or a drop of blood or our single red blood cell flows through the pulmonary semilunar valve into the pulmonary trunk. So we're still in deoxygenated blood. When we arise in the pulmonary trunk, and have a choice to go out the left pulmonary artery or the right pulmonary artery. It's an artery, but it's still deoxygenated blood. So let's take it to the left side. It goes to the left lung, goes through the pulmonary capillaries, picks up oxygen, and now our bright red blood cell is coming back to the heart in a series of vessels known as veins, because it's returning under low pressure. So it's going to return to the left atrium, that's our oxygenated side. And here posteriorly we have the left atrium. It's coming to the left pulmonary veins and entering into the left atrium. It's doing so because of the pressure gradient created by the ventricular pressure pump, getting less and less and less and lowest in the atria. So it flows into the atrium, left side. Ventricles are relaxed at that time, so it flows right through the open left atrioventricular valve into the left ventricle. Now when the left ventricle contracts, it's going to flow, that's going to close the left atrioventricular valve, and it's going to flow up through the center of the heart, the blood pushing, the pressure pushing open the left atrioventricular valve, the aortic semilunar valve, that's right here, the aortic semilunar valve, which is going to come up here into the aorta. And blood's going to then flow through the aorta. When the ventricles relax, blood will flow slightly backwards. We'll close the aortic valve, and blood will flow into the coronary arteries. Okay. So while it's flowing through the coronary arteries, and this isn't on your sheet, but since we're here, while it's flowing into the coronary arteries, the right coronary artery will flow through the coronary sulcus between the right atrium and right ventricle, and will flow around. Some of it might flow down the marginal artery, down the side here, along the border, and supply right ventricle. The rest of the blood will flow around the right coronary artery, continue around to supply atrium and ventricle, and finally flow down through the posterior interventricular artery. Okay. Then on the left coronary artery, which you can see best on here, if you open up this structure, here's the left coronary artery coming out of the aorta on the left side. It's only, like I said, 1 inch to 1.5 inches long. It will branch to form the anterior interventricular artery and carry blood down to supply the left ventricle and some of the right. Or it will become the circumflex artery and travel in the coronary sulcus around to the back and form other marginal arteries down the posterior aspect. Okay. As the oxygen is used up and the capillaries form venules and it returns to the surface, now we have the 3 major cardiac veins. The largest is the great cardiac vein. So that's going to be found with the anterior interventricular artery but flowing in the opposite direction. So here's the great cardiac vein traveling in the interventricular sulcus, and then it will travel in the coronary sulcus with the circumflex artery and will dilate to form the coronary sinus. The coronary sinus will receive deoxygenated blood from the posterior ventricular walls via the middle cardiac vein, and then laterally and anteriorly from the middle cardiac vein, traveling along the marginal artery, and then with the right coronary artery to also enter into the coronary sinus. The coronary sinus is formed as a dilation of the great cardiac vein and receives venous blood via the middle and the small cardiac veins. Okay. And then on this model you can see you can see two. On the smaller one you can see just one individual anterior cardiac veins that go directly into the right atrium and don't go through the coronary sinus. Right?
Yeah.